Okay, now we're going to populate the database. Going to create the literary clock database from the full text search database. So we did it like this because I wanted to show you how you could create the FTSDB for your use in whatever project you have. And now we are going to extract info from that one into our lit clock DB. So we are named it lit clock DB. We're going to do the same pattern as we did earlier. If it doesn't exist, we're going to create it. Okay, we did the cache, we did the lit clock DB file name, and let's see the function. This tutorial will also have a write-up on my site. I'm going to put it in description for people who are not enjoying watching this video. Of course, it's my first video, probably not going to be great, but hopefully some of you will enjoy it. Okay, so the cache and the DB file name, we are going to return a result. Let FTS connection equals, going to create a new connection to the FTS database. Okay. So we are going to check if this exists. No, not good. Path with a small p and then path with a big P. Okay, new exists. So if the path doesn't exist, going to create the literary clock DB. Okay. Okay, so the Rust analyzer shows us there's an error. Control flow. Oh, I think I know. Yeah, forgot to return. Okay. Now let's create the database. Actually, let's create the table. This will be easy enough. It's going to be a classic SQL table. So create table, lit time. We'll have an ID, default ID, which will auto increment and be unique. We will have a time. This will actually note the time for the text represents. Then, of course, we'll have the text, which will probably be a paragraph or a part of a paragraph, the author, and the title, and the link, of course. Okay, looks great. Let's copy paste the fast insert part, like we did before. No reason to go through it again. It's the same issue. We want to do fast inserts and we disable journal mode and such. Okay, now let's insert. We're going to do the insert statement for the clock database. SQL is pretty straightforward. We're going to insert into lit time, text, author, title and link. Don't forget the parentheses. Now the value patterns. 1, 2, 3, 4, and 5. Okay, space these things out so we can see them better. Looks about right. Now we will go to the we're going to go to all of these books, but we have paragraphs, so it's better that we have a hash map that will have the book information from each paragraph, because there are multiple paragraphs from the same book. So we don't want to do a SQL query for each paragraph to get the book metadata. This book metadata is the title, author, and stuff like that. So we're going to hold this data into a map, so it's faster to get the info. I'm going to use the std collection hash map and do a structure for it. Book metadata. It will hold only a few info: the title of the book and the author of the book. Okay. Okay. Looks about right. So this hash map will live during the literary clock DB creation. We'll populate it as we get new paragraphs that have book IDs we don't know about. Now, of course, we're going to do a progress bar, same as before, only we're going to use the all hours and minute combinations. Okay, going to set the style, copy paste from the previous one. Okay, building the clock DB. And now we will iterate through all the times. So for hour in 1 to 13 and minute in 0 to 60. We will generate a time number by combining the hour and minute. This acts like an ID. Now set the position to hour times 60 plus minute. This requires U64, so we cast it. Now we want to get the spoken part of a text of the time, so we will have a function that outputs multiple versions of time to text. Actually, for this example we will only use one, the English way of telling time. You may add more if you want, because I structured the program to support more formats. So this is like an interesting programming problem. Not necessarily interesting, but it's basic programming problem. So we'll have this all formats to text. We'll take an hour and a minute and output a result which will have a string, a vector of strings actually, because you may have multiple formats for a particular time, and an error. Now, so this will get the times. It will be an array, a vector, and push time to text. That will get hour and minute. Now, let's okay, so return okay with the times, and let's write. This will mark up the place where you can add more time formats. Add a function that converts the hour and minute into a spoken English form. Time to text, hour, minute, result, string, and error. Now we're going to do an array with the spoken form of numbers. I won't write it one by one, I'm just going to paste it. Okay, pretty straightforward. Its index contains the spoken form in the English language. Now we're going to do a beautiful match against the minute and output format. For example, when we have 0 minutes, we can say it's 1 o'clock, 2 o'clock, and stuff like that. So we're going to do nums from hour. When we have 1 minute, we can say 1 minute past, and here we insert the hour. Okay, for 59 minutes, we will do a format 1 minute to and insert hour. Okay, now for 15 we have the special form of, okay, let's correct this. Okay, format quarter past and insert the hour. Okay, 30 we have the form of half past, insert hour. And 45 format quarter to insert hour. And now for the rest of the unmatched cases, we have the following. If minute is less than 30, we will output hour, minutes past, number of minutes past hour, and nums minutes and nums hour. And else, if minute is greater than 30, we could have just written else. Okay, format number of minutes to, and we need to do the complementary in the time base, 60 minus minute for the minutes and hour plus mod 12 actually plus 1. Okay, now else, if nothing worked, we will throw an error. This is a sanity error actually, so it's an invalid result, string from bad time. Okay, things look good. Now in the main file, we're going to declare the module utils. So we see if it compiles. Okay, the OK part is not okay. And we're going to use utils, of course, from our crate. All formats to text. So for each time number, we're going to get the all formats for to text. So word times. Now we will basically iterate through all the word times and of course find them in the full text search database. So let's go through all variants. And where time equals time variant, replace. We want to replace this character from the o'clock and we will format this word time. Yeah, we could have done it differently, but okay. So words, we have these words, and now we're going to match on the index. How you say? Well, if the index is 0, we will just output this, and if the index is different than 0, we're going to join with the previous one. This is just so we create the query for these words with the FTS syntax, which you can find going to the link in the description for the SQLite FTS5 extension. Then when we have the query, we will open the connection and prepare the statement. This is interesting. So we will select book ID and highlight from book. So again, if you want the syntax for this, check the documentation for the SQLite FTS5 library. These are the markers, which we will use the HTML bold markers for the text we are interested in, and we're specifying that we want to select from the text where it matches the query we built above. Okay, looks about right. The query looks about right. So we're going to go through each result and insert it into our literary clock DB. To do this, we're going to do a query map with the query words as parameter, and for each row we're going to create a new entry in our database. This will be more complex, so I'm going to do a book ID, and the row get. We need to check each row get because this will actually try to convert to the data type we are assigning to, and if that fails, we will get an error. Let's call the structure book find for lack of a better name. Declare this structure book find. Okay. Book ID, a string, and text, also a string. Okay. Now we should get an array of these. Yeah. So an array of result of book finds. So for entering these, we're going to get the info from the entry. If the result is okay, we shouldn't get any invalid result, and the book ID and the link. We will need to do a scan. This is where text.io comes and saves us. We will separate from the ID, the actual book ID and the link, because in the previous part we combined them when we did the insertion in the FTS. Now we will check if we have the metadata in our hash map. And the logic is simple. If we have the metadata, we're going to use it. If not, we're going to add it to the map via a query. This is basic caching for results, like memoization. Okay. Let's do the query. This should work better because the query in SQLite should be slower than actually getting this from the already populated map in memory. Okay, so it's simple. We did a bunch of joins to get the info. Book with book authors and authors and titles. The SQL query is pretty straightforward. Now get the metadata via the connection. We only query a row, so it should work fine. Still need to map it, I think. So we're going to get the row and return the result, book metadata. Okay, it should be okay, and do the same thing with the get. For each field, title, get, row, get 0, and author, row, get 1. Okay, is it okay? Something is not right. I think I missed. Okay, yeah, I missed a parameter. I should have wrote the book ID in parameter. Okay. So it's okay. Let's continue. So if the result was successful, so if not some, okay. So if result is successful, the book metadata map, we're going to do an insert here. Book ID is the ID and the data. Now metadata, we're going to do a get from the map with the book ID. Okay, yeah, not some, but think here we should go with OK. Let's yeah, okay, but not with a big O. Okay. Oh, we already did yeah, we don't need this because we already checked, but we don't want it to fail. Okay, we're going to rename this to be shorter, but we don't want the program to fail if we didn't, if the query failed, right? Do we? Anyway, let's import the scan and let's should we handle this with if let or just return it and stop the program? This is my question. Okay, so let's handle it with if let. And I don't think this will ever fail, but anyway. Okay, now a link should be populated here. Okay. Yeah. So now, if we have the metadata, we will insert into our literary clock DB time number, the book paragraph, text, and the author, and the title. Of course, the link. And the semicolon. Oh, and yeah, it's actually a tuple, no curly braces here. Okay. Everything looks fine. Let's do another static code check. And if I matched the blocks with the correct indentation. Now, why is this underlined? Okay, yeah, I didn't have a type. We also need to check this. Execute. So this we should break the flow if it doesn't work. Something is awful. Seems we no longer have errors. Maybe we should just run. Okay, progress bar finished, of course. Now we need to actually execute batch to create the index on the timer index. We need this to be fast when we are interrogating for time, so we are creating indexes on the time, the lead time part of the DB, but only after we inserted everything in it, because updating the index otherwise will do a time penalty. So we only create this at the end of the insertion, but I think it's here actually. We need to check the indentation again. I think that's correct. No, the progress should be lower. Progress finish stuff. Okay. Let's copy this lower. And everything should be fine now. Okay, looks good. Everything is all right. Let's cargo run. Cargo build first. Have a, it should be okay. Cargo run. Okay, it did nothing. Created this. Okay. I will debug it some more and come back via transition.